Hello and welcome to this video where we're going to look at the binomial expansion, and this video will sort of be a foundation introduction to binomial expansion, which is an incredibly powerful tool for us in the A-level course. So what is the sort of beginnings of binomial expansion? Well, the beginnings of binomial expansion sort of come from Pascal's triangle. Okay, so Pascal's triangle is a very powerful sort of tool which can help us find coefficients of expansions. So if I had any expansion here, a plus b to the power 0, doesn't matter what a and b are, that value will be equal to 1. If I had a plus b to the power of 1, that expansion would just be a plus b. If I had a plus b squared, using just normal GCSE maths, you get a squared plus 2ab plus b squared, etc., etc. Now, what Pascal, this famous mathematician, found that if you were to carry on doing this and looked at the coefficients of each of these numbers, a and b, then what you get is a triangle of coefficients. Okay, so this first row represents the expansion to the power 0. This represents expansion to the power 1, 2, 3, 4, 5, etc. And the best thing about this triangle is we don't have to keep on expanding to get the next row of coefficients. If we notice, 1 plus 1 gives us 2, 2 plus 1 gives us 3, 3 plus 1 gives us 4. So if you add the numbers in between the rows, they get you the next row. And 1s will always be on the outside. Okay, so this is a very powerful technique, and we're going to see how this can be used in question 1. So question 1, using Pascal's triangle, find the coefficient of 1 plus x to the power 4. So what I do is, I need to sort of think about which one of these rows is for the power of 4. So this one's power 0, power 1, 2, 3, 4. So I've got to focus on this row here. 1, 4, 6, 4, 1. Okay. So those are the coefficients. Okay. Now, in terms of what that expansion would look like, 1 plus x to the power 4, well, what I do know is that I'll have a to the power 4 at the beginning, okay, which makes sense. So it will be, in this case, a is 1, so it'll be 1 to the power 4, which is just 1 on its own. The next thing I'll have is 4a cubed b. So a cubed is 1 cubed times by b. Sorry, a cubed b, which is 1 cubed times by b, which is just here. The next thing I have is a squared b squared, which is 1 squared x squared. Okay. The next thing I have is 4ab cubed. And the last thing I have is b to the power 4. Okay, now if I were to simplify this a bit more, or rewrite it a little bit more, I'll get 1 plus 4x plus 6x squared plus 4x cubed plus x to the power 4. And that is the expansion 1 plus x to the power 4. Okay. So again, let's try and have a go at this again. This one's slightly more difficult, 2x plus y to the power 3. So again, what I need to do is use Pascal's triangle. This is the expansion to the power 1, 2, 3. Okay, so 1, 2, 3. This one here, 1, 3, 3, 1. So I'm going to use this, 1, 3, 3, 1. And then I need to sort of decide what my a and b are. My a is 2x, my b is y plus y. And I'll go to my cubed expansion, which is here, a plus b cubed. So I'm going to have a cubed first of all, which is in our case 2x cubed plus 3 a squared b plus 3 ab squared plus b cubed. So what I'm going to get when I expand all this, I get 2x all cubed, which is 8x cubed. I get 2x squared, which is 4x squared times by 3. I get 3 times 2x times y squared, which is 6xy squared. And I get 1y cubed. Okay, so that's how we use Pascal's triangle to find the coefficients. And as you can see, it's a lot quicker than physically expanding these brackets out. Okay, as long as we remember the triangle. And as I said, the first row and the second row is easy. You can literally generate the rest of the triangle from there. Okay, so that's the foundation of binomial expansion and the formula which we're about to see in the next video. One thing which will just preempt what you're about to see in the next video that you need to take into account. With any expansion to the power of a positive number, the value of the power of a decreases during the expansion. So we had a cubed, a squared, a to 1, a to 0, and the power of b increases. Okay, so it just carries on going up. Okay, so y to 0, y to the 1, y squared, y cubed. Okay, so that's how we deal with binomial expansion. Obviously there's a formula which can help us do this a lot quicker, but Pascal's triangles given the basis for that. So here's some exercise at the bottom of the page which are well worth having a go at.